Today we'll start with the geometry part of a complex number. We'll do some problems related to the geometry of a complex number. If mod of z is equal to 1, then show that iota into 1 minus z upon 1 plus z is equal to tan of argument of z by 2. First of all, we'll try to understand what is mod of z is equal to 1 represents. This represents a unit circle with centered at origin and having their endpoints, that is diametrically endpoints, as a and c, whose coordinates will be minus 1, 0 and 1, 0, and z is any point on the circle which is, in this case we are taking as a fixed point b, which is moving on the circle on the complete locus. So we'll apply rotation theorem on this from AB to AC. So which says z minus 1 by z plus 1 is equal to BC by AB into e raised to the power iota pi by 2, which is the Euler's form, but e raised to power pi by iota pi by 2 is equal to cos pi by 2 plus iota sin pi by 2, which is equal to iota. So this is equal to BC by AB into iota. So it is equal to iota tan phi, where tan phi is equal to BC by AB. But phi is equal to theta by 2, which is actually the argument theta of the complex number z. This angle is twice the angle phi because it is the angle subtended by the arc BC on the center, which will be double the angle subtended by the same arc on the other segment of the circle. So hence tan theta is equal to iota into 1 minus z upon 1 plus z. Second question. The complex number associated with the center of the circle represented by argument of z minus 1 upon z minus 2 iota plus 4 is equal to pi by 4. What does this mean? That the points z, 3 iota and 2 iota minus 4 are lying on the circle, where z is on the circle. So what is given is the argument z minus 2 iota minus 4 and z minus 3 iota is equal to pi by 4, which can be geometrically represented as this. So let us take a center of the circle as z0. So again, the angle subtended by these 2 points at the center will be double the angle subtended by these 2 points on the other side of the segment. So this implies z0 minus 3 iota divided by z0 minus 2 iota minus 4 is equal to mod of z0 minus 3 iota divided by mod of z0 minus 2 iota minus 4 into e raised to the pi iota pi by 2. But these two values are equal because these are equal to the radius. So implies z naught minus 3 iota upon z naught minus 2 iota plus 4 is equal to iota. So cross multiplying, z naught minus 3 iota is equal to iota z naught plus 2 plus 4 iota. So implies z naught into 1 minus iota is equal to 2 plus 7 iota. This implies z naught is equal to 2 plus 7 iota by 1 minus iota. So this can be further simplified using rationalization. So the third question is, for a complex number z, the minimum value of mod z plus mod of z minus cos alpha plus iota sin alpha. So what does this represent? Basically this represents the sum of the distances from the origin and the point cos alpha plus iota sin alpha. So z could be any point lying on the line joining these points, because in that case only the sum of the distances from the origin and the point A will be minimum. In any other case, if z is not lying on this line, then the sum of this distance will be always more than the sum if the point is lying on the circle, on the line. So this implies we want to actually calculate the distance OA. So this mod of this distance is nothing but under root of cos square alpha plus sin square alpha, which is actually equal to 1. So hence proved.